Next up, we've got Daniel from the Science Media Centre talking about tips on communicating your research.
Kia ora koutou. Thank you very much, Rania. I'm Daniel Walker. It's wonderful to be here today. Sorry my name isn't on the program. We're a very small team at the Science Media Centre. I myself personally am a former journalist, radio journalist in particular. I've worked in student radio, I've worked in commercial radio, I've done news reading. I don't have a science background myself, but I've always had quite an interest in it. So the Science Media Centre was founded in 2008 in response to some changing pressures in the media landscape, acknowledging that a lot of journalism media revenue was declining. Opportunities were being lost to cover science well. Lots of specialist science reporters being laid off. And so the Science Media Centre established as kind of a way to help fill that gap, help upskill reporters who are now covering far more than they ever were in the past to get better at covering the complex work of covering science well in the media. So that's kind of our goal. And as part of that as well, we also help scientists and researchers such as yourselves to help communicate your science in a more clear way, because we know that when you are in the weeds, when you're doing that day to day and talking to your peers at a very high level, sometimes coming out of that and talking to the general public can be a totally different field and quite challenging. So yes, like I said, we're a small team, 4 of us, and I'm here today. So the tips that I'm going to be giving today are hopefully applicable across the board in terms of communicating to anyone and everyone, but we focus on the media in particular, and that is because it's one of the lowest effort, I guess, ways of reaching a very, very broad audience. It does take effort, but for the amount that you get, it can only take some very small tweaks in your work to actually reach quite a large number of people. One of the reasons we also encourage people to bother with the media is that if you don't speak up on a topic, then who does? Sometimes the best case scenario is that an opportunity is lost, and perhaps some people who might have known more about your interesting area don't, but there are some worst case opportunities where people with conflicted interests, political motives, things like that, they speak up in the place of independent experts and scientists and can end up in the media as well. So we really do encourage scientists and researchers to speak up. There are some stereotypes I'm sure everyone has about the media, some of them probably warranted, but all journalists as well, we know, in New Zealand in particular, there's a lot of overlap with scientists and researchers looking for the truth, wanting to verify information before putting it out. And they're real hard-working people. I think I have a slide here. So they're real people who are in these roles, and we really encourage you to get in touch with them and make a connection. We also have an impressively broad range of media in New Zealand. So there are niches, there are avenues for almost everyone, even though you might not think your work would end up on One News, there is a way in, there's an angle, and there's other niche opportunities. So to the actual tips of what you can do. Our first tip is to plan ahead. This might sound quite straightforward, but it's really important to remember that the media work at a very, very different time scale to research. And where you're often most comfortable talking about an issue that has been in the media is towards this end of this graph here, where time has passed, you can look back on the facts, you can have all the information in front of you, and you can say something about it with relative confidence. What we find, though, is that the amount of attention on the articles or the thought pieces that come out at that time frame after the news has happened, very, very low amount of attention and very little influence on what has happened before because it's already happened in the past. Where we hope to get scientists and researchers talking to the media or communicating their work in general is very, very early on when the public eye is focused on this issue. So a good example is a volcano erupts and all of a sudden journalists are scrambling for information. They need to know, is anyone dead? How much area has been affected? And then researchers and scientists can come in and talk very early on and talk about the basics. What kind of volcano is this? When was the last time it erupted? Simple information you don't need to be there on the ground for. Things that might be, very, very front of mind for you. You'd think that others might know, but journalists find that information in those situations incredibly useful. So not only is there different time scale, but also a different order of presenting information as well. The traditional order of setting out your research publication, you start with your background, why you're doing this research, what has come before, then go into your methods, and then finally your conclusions, what actually happened. Journalists and most people in the general public will want to hear it the other way around. They want to know what you did that was different first, what's new, what's exciting about it up front. Then once you've grabbed their interest with that, they might ask questions like, how did you do that? How did you get there? And that's when you can start to talk about the methods, the actual way that you perhaps conducted your research. It's not that people don't want to know that information, it's that they potentially don't want to know it straight away. They want to know why they would be interested in that up front. The other thing as well is thinking about your audience when you're communicating this. It's quite different to talking to your peers, talking to fellow scientists. As we can see up here, filtering it through this prism of so what, and this so what is for the audience. If you're thinking of who you're talking to and they're asking, so what, why should I care? If it's a fellow scientist, it's going to be very different to someone in the general public or a journalist who we kind of think of as a way to reach the general public, so they often have quite aligned goals, but journalists have some extra considerations of, is it news? And there are some lists here. These are not hard and fast rules set in stone. They can vary across publications, but here's a bit of an idea of what makes something news. If you're publishing papers at any point, this is something that any publishing scientist has access to, is on the day that your paper is published, it is news. It's happening today. And so whatever other bar of interest that you might have had to reach with how interesting your work is to the general public, to a journalist, you can kind of get a bit of a leg up by you can say, this paper is published today. We see research, or we see news coverage of research happen like this all the time. Research published today in XYZ journal. And so just a quick brief as well on what journalists are wanting. It's generally not that complicated. It's someone who knows more than they do about the topic. Like I said before, someone who can talk about what kind of volcano it is. And they're not going to be like a PhD review panel quizzing you on, the most in-depth questions about your research. They're going to ask really basic stuff, probably things that are in your 101, 201 level papers. But it's because journalists and the general public often, if they're not in your topic, they're generalists. They cover a lot of topics at quite shallow detail, whereas you as researchers, as scientists, are going into depth on something. And so even just a little bit of that depth can be really, really useful. I'll talk about the rest of those as we go on. Another very useful thing to do is coming back and actually stating the same thing over and over again. You'd think that it would become boring and repetitive, and Jonathan Broadbent here does say it is boring, but for these type of topics that are controversial, coming back and actually just saying fluoridation is safe and beneficial. These two headlines are 10 years apart. And he's come back and said it over and over again because people just need reminding of the basics in your field. So I guess the key message here is don't overthink it. Don't overcomplicate how much information they're actually going to want. Sometimes it really is the basic stuff. So when you're preparing for an interview, if you have one coming up, and this can apply to a conference talk or a presentation or anything like that. Thinking about that prism, that so what, why would they care? Why would your audience care? If it's school children that you're talking to, or if it's the general public, or if it's potential investors, thinking about their so what rather than yours. And that can be really hard because we live in our own heads. You've got to put yourself in someone else's shoes for a moment. Thinking about what are your 1 to 3 main points, particularly with the media. If you're having a media interview, there might only be opportunities for 1 point to come across in your interview. And it can feel really frustrating when you have all this information that you want to get across. You want everyone to learn everything, but just 1 point might be all that a listener or a reader takes away from that interview. Thinking about the wider context, how is what you're talking about fitting in? Is there news that's happened on this previously? Do you need to explain, and how can you convey background information succinctly? So there's a bit of a Goldilocks principle. You don't want to over-explain. I think my next slide, yeah. So the best way to be boring is to leave absolutely nothing out. You don't want to over-explain everything in the topic, but at the same time, you don't want to move on so quickly that you're leaving people behind and they're not quite understanding what you're saying. I have desk guides, which you can come see me afterwards. We have some exercises in here, lots of really, really useful information, but some exercises in there on how to really narrow down on what your 1 point is and how you can then expand from there. It's really, it sounds very, very reductive, but once you've reduced it down to the essence, the heart of what you're actually trying to say, you can then expand from there, and you'll find that you can actually go a lot further than you'd think. These are also available online as well. When you're explaining your research, very, very basic stuff here. So using clear and simple language, but it can be tough. You need to practice this kind of thing on your friends and family who aren't scientists. It's not good enough to talk to your colleagues about this and have them say they understand, because they're in the same world as you. And if you're trying to reach people outside of that world, then you need to talk to those people and ask them for their honest feedback. Are they lost? Do they know what you're saying? Are they following? Don't have them politely nod along and say, yeah, that was good. Is there any jargon or acronyms that have become so familiar to you that you know exactly what they mean? Any jargon and acronyms at all, I would say, have a think about. Painting a picture and using concrete, relatable examples or metaphors. This is bonus credit, but if you can do this well, this can really, really help you get your message across. Here's a fantastic example from COVID peak wave times, when we had this letter number soup of BA4s, BA2s, BA 2.1.40s spreading, and people really struggling to keep up with what this means, because it's incredibly important. It might mean that we go back into a lockdown. It really affects your life, but it's really hard to decode from these jargon. And so this journalist here has chosen to use a metaphor of a running race. Jack Lovelock, BA2 is the Jack Lovelock of Omicron, fast, enduring, and unbeatable at its peak. The article then goes on to describe the landscape of Omicron variants spreading, and it uses this running race metaphor the whole way through. So you don't actually need to follow the letters and numbers. It's really this picture in your head of the running race that is what tells the story. Another thing on jargon as well, there has been research done showing that people who are exposed to jargon, any jargon at all when reading something, report things like, I'm not well qualified to participate in science discussions, or I'm not really interested in learning about science afterwards. So it can switch people off the entire field if too much jargon is used. Also thinking about some of these examples here, modelling is a fantastic one. I really like modelling because your layperson is going to think of an attractive person walking down a catwalk. Whereas even among science disciplines, modelling can mean different things. Are we talking computer modelling? Are we talking an animal model? Are we talking about someone who's built a river in their lab at a small scale and runs water down it? These are all models. They all mean the same, they all mean different things. This is a fantastic example to reduce your jargon. You can only use the 1,000 most common words in the English language, and it really takes you to the full extreme of simple language. I wouldn't recommend using that language in an interview, but it's a great way to get your brain as far as possible that direction, and then maybe you can meet in the middle towards something more reasonable. I'll very quickly, we're running out of time, I'll very quickly talk about how you might hear from us at the Science Media Centre. So we have a few planks. So our expert reactions are what we put out to journalists when there's that breaking news event like a volcano or a conference with interesting talks going on. We will gather these comments, we put them out to journalists along with contact details and other information, conflicts of interest statements. So these are very short. You can see they're quotable. Journalists can take quotes directly from these, or they can follow up with mobile numbers afterwards for interviews. We also run an online research clearinghouse. If you ever have any research being published that you think might be of interest to media, when it's accepted for publication is a fantastic time to get in touch with us. We promote a lot of research to the New Zealand media. If we didn't do this, there would be a lot of New Zealand research that would not be in the public eye. Journalists write a lot of stories based on this, and they don't have the time to go and filter through those journals themselves. We also have media queries, so journalists can call us anytime. If you have a topic that's in the news or you think will be in the news, get in touch with us and tell us about that, because then we can provide that information on to journalists. Desk guides, like I mentioned. We also do training for journalists too. It's not one-sided, but we find that when scientists can make small tweaks like this, it can have such a massive impact on the way that science is covered. We know journalists are keen and interested in covering science. They just often don't have the time or resources or training to be able to do it well. Further training, we have our 2-day Media Savvy workshop. If this is something that you're really interested in getting involved in, have a check on our website and you can sign up for that. And finally, our newsletter, weekly newsletter, we round up the best in science news of the week in New Zealand. And so just to conclude, researchers can have a real impact on how media cover a topic when they're accessible, timely, easy to understand, and willing to adapt. So thank you very much.
Next, we have David Jung from the University of New South Wales, Sydney, speaking to us about managing research data at scale, addressing the growing data challenge.
All right, there's a lot of pressure in me speaking straight after an expert, so I'll try to incorporate some of your tips. So thanks for that. Hi, everyone. I can see everyone coming in, so I'll get started now. My name is David. I have been in research infrastructure team at UNSW for the past 5 years, but it's my first time here at eResearch New Zealand, so thank you to the organisers for this opportunity to share our story. And the story starts with the Australian Research Data Commons running a very successful program called the Institutional Underpinnings. During this program, over the course of 2 years, they consulted 25 Australian universities and identified key problem areas that we can all work together. At the end of that program, they published this amazing output, which I believe many of you are aware of, but they also asked the institutions to put their hand up and say, if you want to do more work on some of the prioritized key problem areas, please do so. And obviously we did and said, we'll take 2. For full transparency, UNSW was involved in all 4 of the extension projects, but I will only be talking about the 2 that I led, which were the Business Intelligence and Reporting Project and the Retention and Disposal of Research Data Project. And both of these projects had a single problem statement. Maybe I should call this problem paragraph because it's so long. But it goes like this: modern research institutions face uncontrolled expansion and indefinite retention of uncurated digital content associated with research activities that lead to unmanaged risk, unsustainable cost, and unrealized benefit. An example, unnamed university pays $20,000 per month on deep glacier storage that increases by 20% every year. How do we justify that? What is the data that we're keeping forever? Another example, New South Wales Auditor General has published a report on universities and recommended that we destroy personally identifiable information after its prescribed use. Maybe we can do that for student enrollment data, but can we do that for 3,000 human research projects that university is sponsoring? That's unmanaged risk. So the two projects were related in this way. You can think of the problem having two ends, knowledge and action. So the first project, BI and reporting project, said we need to know X so we can do Y. So knowledge, so actually it's the other way around, right? Knowledge that prompts or leads to action. So for the PII example that I just gave, the personally identifiable information, we need to know where it is and managed by whom so that we can take appropriate action. That's an internal reporting leading to an operational action. But also, it also includes external knowledge sharing for benchmarking purposes. Our data is growing by 20% every year. Is that normal? Does the University of Sydney have the same problem? Because they're a comparable university. And if they don't, what are we doing wrong? So that's benchmarking external knowledge leading to strategic action. So knowledge to action. The retention and disposal project went the other way around. So it's action that requires knowledge. What are the legislative policy best practices requirements on research data retention and disposal? What should we do? And in order to enable that action, what should we know? So it goes from action to knowledge. And these two projects were very much run in parallel over the course of 8 months last year. We ran 3 workshops. First 2 were in hybrid mode, last one at the eResearch Australasia conference, which I know some of you have attended. Who were involved? We had around 100 SMEs across 37 Australian and New Zealand organisations, but specifically ARDC as a funder was pivotal for this work, but not just as a funder, but in the expertise they provided in Max and Nicola, but also the infrastructure of network of people that we could leverage in the institutional underpinnings. We had the partner institutions who had some in-kind contribution to this work, but also acknowledging NESI and RDCC for the close collaboration we did for the alignment for the macro view work. CAUDIT, the IT, so I'm using all these acronyms against the advice from Daniel, but CAUDIT in terms of the IT directors and CAUL, the library, they were involved in the strategic direction setting as part of the steering committee. So what did we find out in the BI and reporting project? We first got our experts to tell us what should we know about research data holdings. And they had all this blue sky brainstorming to say, we want to collect this, we want to capture that. All these data elements that we grouped together into distinct business requirements. But then what these data elements did was they pointed to important characteristics about digital research content that we could convert into a taxonomy. So this is different way of classifying our digital research content, and that's by ethics, privacy, frequency of use and things like that. And we had a BOF yesterday about sensitive data, but that's one way of classifying data, but there are so many other ways of classifying data as well. And these intersections of classifications are what lead to actionable intelligence. So for example, if I have no personal information with no retention period that is closed, not published, and that is inactive, that allows me to make a decision of getting rid of that. So the intersection of categories and classifications is what lead to action. The one last category that needs further mention is the last one there, function and value. And we had a category called research data versus research debris. And this is controversial, but that's why I want to just talk about that a bit further. When we started out this process, it was really interesting because when we said, let's get rid of research data, there were some allergic reactions from the room saying we shouldn't get rid of research data at all. And what I think prompted those sorts of reactions was different definition of what research data means. So we surveyed all of the Australian university policies around research data management and looked at the definition of research data across all of them. There are large agreements there, but there are two main distinct camps. The first camp that says research data is everything that's captured during a conduct of research. And there's another camp that says research data is everything collected, acquired, or generated, used to validate research findings and used to enable reproduction of research. So if we take the latter definition, what's the rest? Right? So that's the sort of conversation that we started to have, and that's why it's incorporated into the taxonomy. Not only did we produce the taxonomy, we also wanted to create a minimum data reporting for the benchmarking purposes that I mentioned earlier. So what we did was the partner institutions went away and evaluated the data elements that were suggested as to whether we can actually capture it. So the three answers available was readily accessible, accessible with effort, or inaccessible. So when all the data elements were evaluated, all the ones that gave the answer readily accessible were combined into a common reporting that we actually tried measuring. So this is a trial of a minimum report across the three institutions. Again, very close alignment with the RDCC's macro view work there. Internally speaking, I don't know if this is true for your institutions, these data don't exist within my team. Right? We're in the research infrastructure. We didn't know we had 3,299 HREC approved projects. We didn't know that we only had 1.4 terabytes of published data sets. We just didn't have that information. Collecting all of that information into a one report allowed us to have insights. So I can say 14,000 terabytes of single copy data, not counting the methods of resilience, but only 1.4 terabytes of published data, so that's 0.1%. So that gives us insights as to how our data publishing strategy is going, right? So that internal report helping us understand our own data holding. But also across the institutions, we can say, okay, we have 14,000, University of Sydney only has 13,000, so we win, but also that we are very similar in size and complexity and also very similar in the research content. That gives us some assurance that we aren't really off. But also, at the same time, UTS is much, much smaller in terms of size, but they're doing much better with the publishing of data, so we can learn from them. What are they doing better? And that we can actually follow. So this minimum reporting has given us really great insights. So what did the project recommend? To adapt and embed a taxonomy in their structures, in the systems and processes, to adopt a research data reporting in alignment with the Corded and Call annual reportings, and also to establish a community of practice, because the taxonomy that I showed you is version 1. We need to keep on improving and making it better, and we need a community of practice. So the second project, retention and disposal project, it's action that require knowledge. What we first wanted to do was wanted to see and document the existing processes that can be leveraged for research data retention and disposal actions. And what are the best practices around that was the question we asked. So we decided to use the research data lifecycle diagram that everyone uses. So we thought, okay, as the data progresses, there are opportunities that we can leverage. But there was a problem. When we surveyed the requirements around research data and disposal, in Australia, we have state retention and disposal authorities, which agree largely between one another. So for example, with significant research and gene therapy research, all the data should be kept permanently. For clinical trials, 15 years. For all other research, 5 years. But as you can see from, maybe not, because the fonts are very small, but what we found was that these are project-centric requirements. It's 5 years after the project has been completed. It's not 5 years after the last access date, right? Inactive data doesn't mean we can get rid of it, according to this at least, because it depends on the project. And that's why the diagram itself was a bit limited in that sense, because the research data lifecycle diagram was about the data, not really about the project, because you can imagine an access and reuse of project A data would spin up project B, right? My PhD supervisors may disagree because projects never end, but the project manager in me can say projects have a start and an end date, right? That's a project. Also, this diagram didn't really provide a sense of data volume changes that we wanted to document when proper retention and disposal actions are taken. So we unraveled this diagram into more of a linear form there, retaining all the stages, but in a linear fashion. And we asked the experts, what are the operational opportunities at each of the stages that we can leverage for metadata enrichment and data retention and disposal actions. So some of the ones, for example, ethics application, the researcher will say, this is a gene therapy research, then the data associated with that project should be kept forever, right? That metadata is captured in the plan and design stage. External data use, when you're capturing, when you're receiving data and you're agreeing on a data sharing agreement, they stipulate the retention disposal actions, and all of that should be captured. And if those metadata enrichment and data disposal and retention actions are taken, this is what we propose, that data will increase during the first 3 stages of the life cycle, but it will then decrease during evaluate and archive because only the research data that needs to be kept will be kept, and then so on and so forth. And at some of the operational opportunities, we try to do best practices analysis. So what actually should happen at some of these operational opportunities. Of course, you can't read it. It's all written in the report. Just wanted to show you this to say that we did it. And the partner institutions have tried to do a gap analysis as to what they're currently doing, compare that with the best practices, which is on the far left-hand side. But what we soon realized, it wasn't really the silo of the opportunity. We need to connect the opportunities together. So what we tried to do was use what's called the sentencing states to find out how these connections happened. What are the sentencing states? So again, it shows the connectedness between the 2 projects. In the taxonomy, I showed you a category called sentencing. We have permanent, within minimum, within maximum, and no retention period. And we call them states because category seems more static. We're calling it state like the gas, liquid, solid state because data can move around different states. So this actually isn't in the report, so it's a true eResearch New Zealand exclusive. So when data is generated, you can imagine a situation that the data has different sentencing states. So a PhD candidate downloads a publicly available data set off the web, probably has no retention period. It's not our data. We don't own it. We're not the custodian of it. It's available in public. So it has no retention period and can be gotten rid of according to the normal administrative practice, for example. But if they do derive data from it, maybe it goes into the within minimum retention period of 5 years, let's say. But if they win a Nobel Prize and it becomes a significant research, maybe it goes into the permanent retention category or permanent retention state. And if so, maybe we should transfer the custodianship to someone who can do a better job. Is it the state archives? Is it the institutional archives? Because it's a matter of preservation now, because we can't trust a PhD student to keep that forever, right? We need to transfer that custodianship. But there's also the category or state of maximum retention, and that's like the DSAs that you signed or the consent forms that the participants have signed. There are stipulations there that says we will get rid of the data after the retention requirement has been met. So there is that state as well. So what the metadata is those errors. What are the events? What should we know about these events? And what actions does those events prompt? Are those metadata? And that's all written up in the report as well. But one key question that this raised was, who actually does it? We need to collect all these metadata, we need to act on all these metadata, but who are the actors? And the key problem here is that the researchers are key actors, but not really a key beneficiary. So how do we convince them and to collaborate with us? So lots of recommendations here. Think about the states of sentencing states in the data retention and disposal policies. Document the roles and responsibilities because custodianship is scattered through the institution. Integrate and automate because manual is not going to work because you have so much data. And researcher engagement, we need to really convince the researchers. And lastly, the community of practice, the same recommendation for the first project. This is the QR code for our final reports. Please feel free to scan and have a read. I'll just stay here. Please keep me in the shot so I can send it to my wife and convince her that I am actually working, not holidaying in Wellington without her. So what's next? The partners are trying to implement the project outputs. We've been preaching a lot, but can we actually put that into action? So UNSW will be doing some projects in uplifting the research data storage over the next few years, and we will be adapting and embedding the taxonomy, for example. We are engaging with Cordit about the community of practice and the data reporting, how we can do that. We're also having some international conversations, yet another acronym, RDA, Research Data Alliance. But more immediately, in this conference, we have the BOF later this afternoon, led by Claire from NESI, and there's also another BOF on Friday tomorrow. I just want to thank everyone in this room, but also the funder and close collaborator, ARDC, and the partner institution, and all the experts that we've consulted throughout this process. Thank you.
Hello, my name's Justin. I'm from DDN. We're a storage vendor. The amount of research data is an important figure because it directly affects cost. It's a very easy question to ask, but it's a difficult question to answer because data for a university is normally distributed across campuses, faculties. It sits on machines, servers in machines. It usually is not centralised necessarily. So how did you determine how much research data, and it's also replicated often, how much research data you have?
So in this round, we asked them. We asked all the people that we could find, how much data do you have? And then we collated it all. And that's exactly what MacroView people have done as well. But we do have a talk from Katie soon, which could actually show us the way, the future, where we don't actually have to ask around. So I'm looking forward to that, and everyone should really listen to that as well.
Okay, thank you very much. I really dislike standing in front of lecterns, but I'll just have to get over that. This is a declaration. It's intended to provoke. I'm going to talk to you about a bit of work, a small piece of work that we've been doing over the last couple of months with a group of interested individuals. That's one of the ways that the ARDC has operated in this space. We bring people together and we help drive consensus and identify opportunities over which we can do. One of them was brought to us in this context, and it was brought to us as an observation that data storage infrastructures in particular, so we're not talking about the analytics or the compute infrastructure, but storage was increasingly high performance. There was really quite obscure scaling concerns in many of the universities that we talked to. There were rich access models that we've heard a lot about recently. And implementations were often very specific. This is quite common, and I don't think I need to explain that to very many people. But they often advanced in a really ad hoc way, and that was sometimes driven by commercial concerns over feature concerns which are more pertinent to a research institution. And we suggested that actually if we had an underpinning model that talked about the sector rather than implementation, then we might be much easier to meet a subset of requirements and avoid the idea that interoperation was a lower priority and avoid serving limited domains or even addressing the poor scalability issues. We had some interesting persons and we posed an interesting question. Can we specify a set of features that supports all implementations irrespective of the technologies or in the domain? And people will be familiar with some of these. I put them down as interesting persons with an interested question. So we landed on the idea that this a reference architecture approach may be helpful in this case. And I will say it's a proposition. It's not something that we've decided on lightly, but it wasn't our intention at all to comment on how information should be managed. David and the team have done a great job at talking about that, and I'll try not to torture the English language too much. But it's not designed to solve issues or day-to-day issues like formatting or crunching data or quality, nor is it an intention to promote any particular technology over anything else. And actually my role in this space, in this group, was to constantly flag when there was the overwhelming desire to resort to instantiations to solve problems. And this is something that we have to fight in order to understand the concepts that sit behind any sort of design in this in the intended architecture. So we wanted to abstract, we wanted to conceptualize, we wanted to make it agnostic. And from my particular position, is this a useful resource to inform system development, for example, in a national strategic framework? And most importantly, if we were to invest strategically, would this help? So first thing, is this really new? I've been involved in a couple of activities previously that sounded quite similar to this. There's certainly been some international activities with, the Global Grid Forming and Global Grid Forum and the Research Data Alliance. What we found was the specific systems that we looked at were often domain-specific, and they were tied to implementation technologies. And when you're investing large sums of money, it's almost a very difficult thing to disentangle yourself from those technologies. So few implementations could show us agnostic attributes. And the purpose was often driven by choices that any particular institution had made. And that served sometimes to disincentivize interoperation. The generic systems were often not sufficiently abstract to guide other implementations. And we had products and services that would limit future feature development or future implementations. And so we had this tension that we needed to control. And I like to think of it as a bubble expanding and surface tension. How far can you abstract before the whole thing explodes and it becomes completely useless and just a thought experiment? So we struggled with this for quite some time. And we came out with our 8 abstract properties that will be very familiar to all of you. The first stage of this was to define and characterize those abstract qualities, but actually the more important and the more interesting part for me was the relationship between those abstract properties. And so I'm just going to go through them all, one by one. I'll speak quickly. I don't like throwing out lots of wordy slides, but I'm afraid I can't get away from this. First one, resilience. It's really important to keep reminding ourselves that the research data are the foundation of research and the evidential record of that research. Codes of conduct are increasingly reminding researchers that this is the case. It's always been the case. It's just we've been lost. And if datasization becomes a convention, then it's very important that the consequences of anything that's cited implies that it exists for as long as the cited record recalls. So we need to also accommodate the idea that there is this expectation that at least some of those data will be available for reuse, and the assurance that it's going to exist over the period of time that David's talked about as well. Discoverability, this is also something that is very important to recognize, and I don't think it's news to anyone that some organizations, let's say organization X, struggles to classify the data that they contain. I know in my own last 3 years at the ARDC, running an investment program called the Data Retention Project, which asked organizations to classify the data that they had in a very minimal set of metadata. A lot of organizations struggled to do this. And that presents a real operational concern. So the idea that we're transforming this characterization into an operational imperative, I think would serve the two camps of both research data management, but also the storage system management that is so necessary these days. It should be found easily, even if it's not openly available. Carol gave an excellent keynote about that this morning. If we're expecting organizations to treat these data as assets, then we shouldn't be surprised if they start treating them as assets. And that's often can run counter to our dogma of fair. Accessibility, again, I've always thought that collaboration has been existing in research for a long time. The control over that is something that's often relayed to the researchers, and it's not always expected. But as a systems design, rich access is really an ongoing concern and an ongoing challenge for infrastructure providers, not only in storage, but also in networks. The technical solutions for this will possibly not transfer very well between domains. So we gave it its own special conceptual concept. Governance is something that I've been very interested in for a long time, particularly around the absence or trouble of licensing reuse, and even recognizing the roles and the quite important roles that exist in objects of research. It's been very easy when the published record is transferred entirely to the academic publisher. You don't have to worry about it anymore. If we're going to take control of the data, and we have to recognize that ownership and accountability needs to exist in that as well. And I think that's an operational concern that is often overlooked. And it's really, really important to keep this at the beginning rather than as an afterthought. I think most of us in this room have felt that at some stage or another. Scalability, not something that I want to talk too much about, other than it is continues to be an issue. And we're starting to find some solutions that may help our organizations deal with that challenge a lot better. But we often find, and certainly I found this in my data retention project, even the small scale institutions, they'll start out small, but they recognize that they're going to be growing pretty quickly. If you're going to grow to the multi-petabyte scale, it's not very wise to put all your eggs into one basket, and often you'll need different technologies anyway. You end up with quite a mish. Versatility was something that I didn't have a lot of, I had quite a bit of trouble actually understanding in our discussions, but these really talked about how the different access requirements needed to be flexible enough to take into account the heterogeneity of the research. I know from a previous job, lots of people really liked the idea of a highly accessible cloud infrastructure, but that didn't scale very well with a lot of the high volume people. But you must really, one thing that is common is you must really need to be able to deliver storage solutions in various ways. And that's not trivial, and that is not very efficient. Security, I don't want to go on too much about this because there is plenty to go on about security, only that impact management, risk management, and the relationship to other concepts, very much like governance, need to be very, very well thought out and from the beginning. So the question is then posed, well, there are lots of enterprise systems that are able to do this. We had a quick scan, and I'm not going to talk you through these because take a photograph. Mostly to say that enterprise systems are generally concerned about fulfilling the requirements of the institution as an internal organization, and that's completely understandable. We often find that research is focused outside the institution as much as it is in, and it's a stringier beast to hold together. So, just to summarize, we've got our 8-level, high-level abstracts. We invite people to challenge us, and we think that they're a solid set to start with. We've had a look at some real-world systems. We'd like to look at more. We'll come on to that in a second. And we're assembling a maturity model if we're going to start assessing things, and I don't use that word in a horrible way. If we're wrong, we'd like to be told we're wrong, and we'd like to have an understanding of how we're wrong so we can amend our model. If it finds that what we've done chimes with you, then we'd really like to help you establish a way to make your storage systems a lot more effective. So, cue the lone figure standing on a mountaintop staring into the distance. What's ahead for this short project? We're going to be validating what we've done so far. There's a whole specification that sits behind this that isn't quite yet public. And we're going to take it to a number of different organizations and start looking at what they're doing. As I said, if we're missing something, we'd like to extend the model, but we don't want this to turn into a massive specification. We want this to remain at the boundary of almost exploding. If the system is missing something, then we'll help you define it. What I would very much like to do with this piece of work is start to define the narrative and the relationships between these different concepts, because that's where I think a lot of value exists. To that end, we're going to be running a BOF at Supercomputing Asia in a couple of weeks. Those of you attending, I encourage you to participate. I belong to the ARDC, and one of our delivery mechanisms is that we are focusing on 3 strategic pillars, they're being called, which are focus areas. And what I'd very much like to do is to take this specification to a number of the storage operators in those focus areas and start to see if our model helps them deliver the sorts of impact and enduring infrastructure that they are interested in doing. And Rosie will be talking about that tomorrow morning. I encourage you to attend that talk. Conference time again, eResearch Australasia, again in October. We'll be presenting at least 8 months' work there, so I'm very excited about that. And you can't work for the ARDC and not bring to your attention that we're going to be hosting International Data Week in Brisbane in 2025. So please do keep that in your diaries. It'd be great to see you there. Brisbane's a great fun place, as you can see. If you have any questions, I'll happily take them. If you don't want to talk in a public forum, I'll happily listen to you in breaks and also in emails. But we invite people to challenge what we've done, and we'd very much like to turn this into something that's a lot more useful to the community. Thank you very much.
We do have a few minutes if you want to ask any questions for Max.
Richard, yes. Because ultimately we want to approach this as a vehicle of design. We want to be able to explain our abstract concepts in ways that will enable people who are responsible for the underpinning, the real tangible architecture, to put together something that fulfills the requirements that they need. We like to think of it as a plan that can be adapted according to your requirements that sit, but we consider them to be minimum requirements. That answer your question, Richard? Okay. Yep. I may have tortured the English language a little bit too much in this talk, but yeah.
You were hinting at this with your conversation about narrative between your 8 elements here. I was really interested in your slide where you were talking about the differences between research and enterprise, and I think, you know, for those of us that end up a bit more on the enterprisey side, we get very interested in that boundary when you go from the research domain into the enterprise domain. Can you talk a wee bit more about, are you thinking about fleshing that out? Does that remain a binary? Does that become more of a smorgasbord of options we can choose from, and how might this architecture help us make sense of that?
To the extent that I can answer that question, the idea was that most of us who have been involved in operational storage have come across this at some stage or another. It's a significant investment, and often you have to trade off between what something can do and what you want it to do, and that happens everywhere. Okay, what we wanted to do is to say, okay, let's recognize that that's real, but also recognize that different institutions will have a different appetite for a particular trade-off. So it was very important for us to say, okay, well, if I'm a really large research-intensive university and I'm struggling under the amount of data that seems to be generated that I'm expected to look after, then there's technologies out there that can help me do that. But they're of no particular use to a smaller university that doesn't have a very large overhead and may actually consider outsourcing all their issues to a third party. What we wanted to do was to say, okay, well, you need to consider these things as decisions that have consequences that impact other components of the architecture. And that we haven't got there yet, but that was the intention of that slide, was to say, okay, well, you know, it looks like a binary right at the moment, but different institutions are going to have different reasons for having particular technologies, and we need to accommodate, the model needs to accommodate that flexibility. So I guess we want to avoid the binary, but that's where we're starting. The whole idea of the design is to help institutions understand their requirements given the profile of risk or budget or anything else that they have that's the pressing concern. And I know that it's very easy to put those up there as if they're inconsequential because they have their own concerns as well. But it wasn't meant to be binary, it was just to illustrate the differences that people have experienced. No further questions? Thank you very much.